All right, ladies and gentlemen, we are continuing today with the sine function. Going to take a look at some details, work on a few more graphs, and see how we're doing. So, all right, first one here. Use the graph to the right to find the value of y equals sine theta for each value of theta. Now, let's do a couple of things here. Let's darken up our axes a little more here so it's a little easier to tell where everything is. As we talked about yesterday, our typical sine pattern is from 0 to 1, or my max, 0 or -1, or my min, and back to 0. So this is a classic sine graph, nothing cute. So now, as I'm taking a peek at this, okay, the first one, now this is interesting. Well, we'll start with an easy one, and then we'll go into some of the strange stuff here. Pi over 2. Okay, I go to pi over 2, I go up, y value is 1. Okay. But all these other ones, I don't see them on the graph. I see pi over 2. I see pi. I see 3 pi over 2. I see 2 pi. I don't see any of these. What the heck, Hardy? Okay. Here's how we're going to work through this. We talked a little bit yesterday about how when I have the choice of building my graph, I always know I'm going to have pi over 2 pi, 3 pi over 2, 2 pi, and I can multiply by whatever the b value is. I don't have that as an option this time. So what exactly do I do? Well, let me tell you what we do. Basically, I'm looking at this and going, okay, here's 0 and here's pi over 2. So if I look at that this way, I say, okay, here's 0. Let's ignore pi for a minute. So let's just say this is 1/2, this is 1, this is 3/2, and this is 2. Same values along here. I'm just kind of eliminating the radians for a minute. You're like, why would you do that? Because our brains can wrap around regular numbers a little bit easier than they can all this abstract stuff. So I look and I say, okay, what's in between 0 and 1/2? Now, if your answer is, oh, here's how we get around that. You can either add these two values together in your calculator and divide by 2, because we're looking for the midpoint, we're looking for the average. Or, when you divide something by 2, it's the same as multiplying by 1/2. So I look, okay, so to get this value, what's 0 plus 1/2 divided by 2? I punch it in my calculator, I do it in my head, I get 1/4. Okay, I go to the next place that there's a blank. And I'm going to show you a pattern so you don't have to do this for every single one, but just stick with me for a minute. Take my two endpoints, 1/2 and 1, add them up and divide by 2. You should get 3/4. Now some of you may say, wait a minute, I didn't get that. Remember, your 1/2 has to be in parentheses, and so does your entire quantity. So if you didn't put your extra set of parentheses, that'd be y, or maybe you used 0.5. But we'll see. And here's the pattern. Once I get this first value, 1/4, if I just keep adding a fourth, this would be 2/4, but 2/4 reduces to 1/2. 3/4, 4/4, or 1. 5/4, 6/4 reduces to 3/2, 7/4, and so on. So when I'm looking at these pi measurements, I'm basically just putting the pi back in with each of those fractions. So if I'm looking at pi over 4, I look at pi over 4. Well, it's a little more than 1/2, but it's not to 1. I don't know. We kind of guesstimate. 0.7 looks about right. If you put 0.653, again, you're close. But being able to figure out these values is going to be an important part of that. Okay? And we'll see that again here as we do some other pieces of our worksheet. Okay. Determine the number of cycles each sine function has in the interval from 0 to 2 pi. Find the amplitude and period of each function. Okay? We're going to look at the first couple here. Does that seem like a good idea, the first couple? Yeah. So I look and I go, okay, from 0 to 2 pi. Hardy, I don't think this goes to 2 pi. This says pi, even though it's kind of squished in there. So I'm like, okay, so here's my axes. So There's 1. There's 2. There's 3. Okay? Because here you're like, well, how do you know that's 2 pi? Well, here's 0. 1, 2, 3 lines got me to pi. 1, 2, 3 lines would get me to 2 pi. I've got to use a little common sense here. Okay? I know that can be rough. Again, just saying. We're going to skip number 6 because number 6 is strange. You got a zoomed in version of it, and I wouldn't do that to you, so I'm just not going to worry about that. But when you get to number 7, I have a hint for you. Okay? Watch carefully and learn. So I'm like, all right, sine function. You're like, wait a minute, sine functions go up. Why is this going down? Okay, it may have a negative a value, but let's work it that way then. So we're going to go 0 min, 0 max, back to the start. Okay, there's 1. Down, up, down. There's 2. Notice something. 2 cycles to get me to pi. 2 cycles to get to pi. How many cycles to get to 2 pi? I think you can figure that answer out yourself. Okay? Again, we're having to stretch our thinking processes here a little bit. Let's keep rolling. Okay, I'll do the tricky one here on number 8. I'll do a couple of the ones that are a little trickier, and some of it I will leave to you, though. Sketch one cycle of the sine curve. Write an equation for the graph. Okay? So, get my graph ready here. 1, 2, 3, 4 lines. Okay, if I know my period is pi over 2, I know that's my last line. If my amplitude is 2, we go up to 2, and we go down to negative 2. Okay, those are the things I know for sure. How do I get this stuff in here, though? And we started to talk a little bit yesterday, and I'm just going to kind of do a card here on the side to let us see this. We said, okay, we always got 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are our parent. Those are our base points. But this time, this is pi over 2. So I need to figure out my b value. So we chatted a little bit yesterday about how I can do that. If I know that 2 pi over b, my formula for finding this, equals pi over 2, because I know that's what it is. It tells me right here. I'm going to cross multiply. And then to solve for b, I'm going to divide by pi. My b value is 4. You're like, okay, so what does that mean? Well, normally it means when our b value is 4, we would divide by 4. But we're going to do the inverse of that. The opposite of dividing by 4, multiplying by 1/4. So what I'm going to do here, and I'm going to use a sticky note so I can use this little cheat sheet of mine over a time or two, is I'm going to multiply each of my base parts by 1/4. Because once I do that, multiply across, multiply across, multiply across, and multiply across, and reduce, I should get my last value at the last value here. Okay? So having a little cheat sheet to yourself on the side with these, and then just multiplying by the inverse of your b, is how we're going to do this. And for some of you, you're going to be like, that's a lot of work to do. Well, that's mainly the only way we're going to be able to get those values. And then I got to remember with my sine, when I'm doing my points along these lines, and I'm going to do that in another color here. With sine, we start at 0. We go to 1. We go to 0. We go to negative 1. And then we go to 0. But I have an amplitude this time. So each of my 1s are going to get multiplied by that value. So my zeros will stay the same. This will become 2 at my pi over 8. Back to 0 for my pi over 4. Negative 1 times 2 is negative 2 at my 3 pi over 8. And back to 0. Okay. If I get lucky and my period is 2 pi, that's just going to be my parent graph. I'm not going to have to do anything cute. Just sketch the graph and go about your business. Okay? So let's see here. Oh, which one am I going to do this time? I was nice before. Am I going to be nice twice? No. Am I really not going to be? No, I'm not. Oh, yes, I am. Who am I kidding? So I look here. I'm going to get you started on this one. Okay, I notice a couple of things. My A value is negative 2. Okay? Which again means my values that I'm starting with, we're going to remove this sticky note this time, are all going to be multiplied by negative 2. So it'd be 0. 2 times 1 is negative 2 at whatever my first value is. Back to 0. Okay, negative 2 times negative 1 is positive 2, and then back to 0. But what about these guys? Well, this time I'm given the B value. It's 4. You're like, well, isn't that coincidence? We just did that a minute ago. You're right, we did. When we got B equals 4, so we're going to multiply our radian measures by 1/4 again. So instead of these, we multiply them by the inverse of B. So maybe I wasn't as nice, I guess, as I was making myself out to be. And then one more on this side. And yes, we will be seeing this some more before we go into a quiz, so don't panic if there's some issues right now. Okay? So now, I look through here and I go, woo, 12 looks like fun. Find the period of each sine curve, okay? So first, before we can find the period, we need to find B. So here I notice, okay, here's 0. Here's 2 pi. How many cycles do I do? Okay, there's 1. There's 2. There's 3. There's 4. So B equals 4. So my period is 2 pi over B, and I reduce it. My A value, it opens up, I don't know. It's like, here's 1 and here's 2. That's kind of in the middle. Well, I guess we'll call it 1.5. Okay, I got to pay attention to my amplitude. So y equals 1.5 sine. My B equals 4 for theta. Because again, that's my B value, not my period. Okay? And then you're going to have to do that on the next one. Kind of think through. Take a peek at the key if you need to. And as you flip over to the back, you notice it's just 4 more to be able to sketch the graph of the function. Okay? And on this, sketch each function from 0 to 2 pi. Sketch each function for 1 period is fine. Okay? I'm not going to make you stretch it and keep continuing it. If you can do it for 1, you can do that. Follow the examples that you did on the front and we'll try. And if you have some questions, I will be happy to answer them for you. So good luck with this. Do try it. Look at the key. Work with each other. Talk, talk, talk. Help each other. Thank you. See you soon.